Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
All right, here we go with lesson 6.2.4, using a table to write equations. Okay, so the last few lessons you used algebra tiles and equation maps to solve problems in which variables represented specific numbers. The tile and equation map tools are related to the processes you have used to solve word problems in which a specific value is unknown. Today, you are going to connect these two tools and the expressions you wrote using part of the 5D process to extend your repertoire for solving problems. So we've already kind of done this already. Back in chapter 5, I sort of showed you a preview of what we're going to do in this lesson, but this is the official lesson where we solve algebraically instead of using the guess and check process when solving word problems. Okay, so here's the first problem. What we're going to do is we are going to solve this problem, or at least try a few trials and see if we can get to an answer, and then we're going to convert over to solving algebraically, so you kind of see the advantage of solving it algebraically when the specific unknown quantity that you're looking for your trial number is not a real obvious one that you get after like one or two guesses. So let's read a little bit about the Great Lakes. This is where I grew up. I was born here. I went to college, or middle school, high school, and college right around there before moving to California. So I'm very familiar with all of these lakes, and I've been in actually every single one of them except Lake Ontario. Although I was at Niagara Falls, so I guess that kind of counts sort of. All right. So anyway. The Great Lakes contain the largest amount of fresh water on the surface of the planet. Combined, the 5 lakes, that would be Superior, Michigan, Huron, Erie, and Ontario, contain 84% of North America's and 21% of the world's surface water. Okay, so let's read through the problem and the information. It says the amount of water in Lake Superior, here's Lake Superior, is 1,720 cubic miles more than the amount of water in Lake Michigan. So since it's being compared to Lake Michigan, I'm going to highlight Lake Michigan. Now let's read about Lake Huron. Lake Huron has 330 cubic miles of water less than Lake Michigan. So both of these are being compared to Lake Michigan. So it seems logical that we should start with a number for Lake Michigan and then figure out how much water would have to be in Lake Superior and Lake Huron, given these two definitions that we've got here. The last piece of information is if the total amount of water in the 3 lakes is 4,930 cubic miles, so 4,930 cubic miles, how much water is in each lake? So when we declare our answer, we're going to declare for each lake. All right, so let's start off. I'm going to have you write down all of our variables, right? You got 3 different lakes that are shown here. Write down the names of the lakes. Both of them are being compared to Lake Michigan, so make Lake Michigan your X and write your definition for the amount of water in Lake Superior and in Lake Huron, and any other information that you think is necessary. And then we will begin the process. So go ahead and take some time to write down your descriptions and your definitions for all of the variables. Alrighty, let's see what we got. So you got your 3 lakes, right? Lake Michigan, Lake Superior, and Lake Huron. And if we make Lake Michigan our X, then Lake Superior would have to be X plus 1720, since this has 1,720 more cubic miles of water than Lake Michigan, and Huron has less water, right? 330 cubic miles less, so that's X minus 330. We also need to acknowledge the total, which is 4,930 total cubic miles if you were to take all the water from all 3 lakes. So as we set up, these are our definitions, but we're going to put them here for our 3 lakes. The Michigan is the X, the Superior is X plus 1720, and the Huron is X minus 330. Now remember, we need to add up all of these, and the total is supposed to be 4,930. So when we make up our trial numbers, we are going to adjust. We're going to make it up for Lake Michigan and then adjust it for the other two lakes and then add them all together and see what the total is. So I started out with number 1,000. When you add 1720 to 1,000, you get 2720. When you take away 330 from 1,000, you get 670. When you add the 1,000 plus 2720 and the 670, that adds up to 4390, which if you're dyslexic looks the same, but it's not. It's too low. So we make an adjustment, and maybe I add a couple hundred to Lake Michigan. That makes this 2920. That makes that 870. When you add those together, it's 4990, and that's too high. It's a lot closer, isn't it? So some people would go back down to 1,100, but this is only 60 away. We're really, really close. So I'm thinking maybe let's just adjust it down to 1,190 and see what we get there. Well, after adding the 1720 to 1,190 and taking away the 330 from 1,190 and then adding those together, that gives us a total of 4,960, which is still too high, but it's closer. This was 60 away, this is 30 away. I'm pretty sure we know what the next one is going to be. Take it down to 1,180, and that's the combination. That works. And it took 4 trials to get there, not too bad, but algebra is going to be a lot quicker. So let's go back to this section right here where we wrote the algebraic equation to model this situation. This is Lake Michigan. Actually, hold on for a second. Let me color coordinate. I think, what did I do here? Did I do Michigan is in green? Yes. So Lake Michigan was this quantity right there. Lake Superior was this quantity. Lake Huron was this quantity, and the total was this quantity. So we put all that together into an equation that we're going to use to solve for x. And once we know what x is, we're going to know Lake Michigan's water level, or the amount of water in it, its value. So what I'd like for you to do now is I'd like for you to pause the video, and I'd like for you to work through the process of combining like terms and simplifying this expression on the left, and then solving for x. Go ahead and do that now and see what you get. All right, so you would have combined 1, 2, 3 x's and then added 1720 and negative 330 to get 1390. So now we want to figure out what the 3 x's were before we added 1390. So let's take 4930 and subtract away 1390. Let's see what we get. 4930 minus 1390, and we get 3540. So that means that 3 x's had to be 3540, since 3540 plus 1390 is 4930. So now what do you multiply times 3 to give you 30,540? Well, let's grab our calculator and divide that by 3. 1180, that's our magic number. So we got the same thing algebraically as we had gotten when we solved it using the guess and check trial and error kind of a process. So what we would do now, if we had not already done this step right here to prove that it's correct, you would want to go and check your definitions. We know Lake Michigan is 1180, right? That's what x is equal to. So when I take it, I add 1720 to that, because this is 1720 more than that, we get 0, 10, 9, and 2. We would get 2,900 for Lake Superior. And then we do the same thing, but with Lake Huron, we would do a subtraction where we would subtract 330 away. And you get 0, 5, 8, 850. So add all those together, prove that they add up to the total we want it to add up to. Double check to make sure that each one of these meet our definitions compared to Lake Michigan. And once we have all of that secure and true, and we are fully confident, we declare our answer. All right, let's take a look at a new type of a problem. This one involves Olympics and Olympic medals. Okay, so it says, as you saw in problem 93, sometimes organizing your thinking using the 5D process to solve a word problem involves a lot of work. Yes, it does. Sometimes the tables are very complicated or the numbers require many trials before you find that answer. How can your new equation solving skills help you solve word problems? Well, we just did it, right? Use equations and solve your equation instead of doing the guess and check process. So let's try this again. this time with a different situation. While looking at the country of Jamaica's results from the 2008 Beijing Olympics, Cameron noticed that the number of gold medals Jamaica received was twice the number of silver medals. Okay, so let's start with gold medals. Number of gold medals received was twice the number of silver medals, so I'll put silver medals here. She also realized that Jamaica received one fewer bronze medal than silver medal. So that's great. Both of those are being compared to the silver medals, so it seems like we might have our trial start with the number of silver medal, then double that number, and then take one away from that number, and that could be the number of gold and bronze. And then the last piece, all together, they received 11 medals. So we've got a little table over here that has been started, right? We've got our gold, silver, and bronze medals. The total is what you get when you add all of them together, and we're going to decide if we get the number 11. Now notice these definitions here. That's kind of what we would do. We would say gold would be 2x because silver is 1x, and there's twice as many gold as silver. The bronze is x minus 1, and the total would be 11. Okay, so how did she represent the number of gold and bronze medals? Same way that we did. The gold represented, or was 2 x's, and the bronze was x minus 1. So if we were to put all of this together to create an equation that would be used to solve for x, and then therefore know the number of silver medals, we would add this plus this plus this. The total sum of all three of those has to equal 11. So we would write the equation like this. So what I would like for you to do is go ahead and pause and solve for x. Once you have the solution for x, then the question that we're answering is how many gold medals did Jamaica earn? Okay, so go ahead and work through that process, and then when you are ready, we will reveal the answers. Okay, so here's the work that we're going to do. We're going to start with 2x plus x plus 1, no. 2x plus x minus 1 equals 11. So we need to combine like terms. So let's get all the x's together. You have a total of 4 x's there, minus the 1 is equal to 11. Now, I want to know what the 4 x's were equal to before I took away the 1. So let's add that 1 back in. This must have been 12, since 12 minus 1 is 11. So 4 x's has to equal 12. And now we have to figure out what x is equal to. What do you multiply times 4 to give you 12 for an answer? Well, 12 divided by 4 is 3. That means x has to be equal to 3. So what is the value for x? X is 3, and what does this represent? It means that Jamaica must have earned 3 silver medals in these Olympics. Now, before we declare our answer, let's make sure that we check everything to make sure everything is correct. If the number of silver medals was 3, then the number of gold medals would have to be equal to 6, correct? Because there's twice as many gold as silver. And the number of bronze would be 3 minus 1, which would be 2. So when we go through all of this process, 6 plus 3 plus 2, is that equal to 11? Yes, it is. Now we can fully declare our answer. How many total gold medals were earned? There would be 6 gold medals. Explain how you know? Well, it's twice the number of silver medals, and we solved the equation and said there were 3 silver medals, so there must be 6 gold medals. All right, so these are the last 2 problems. What we're going to do is we're now going to fully transition into solving using equations instead of using the table for the 5D process. Now, I say this, but I want everyone to understand it is totally okay for you to use a table. If you are not quite ready yet with your solving of equations to do this algebraically, I just want a correct answer. So if you want to use the tables to get your correct answer and you feel comfortable doing that, it's absolutely okay to do that. But if you can solve it algebraically, you are really going to save yourselves a lot of time, okay? So this suggests that it might be helpful to get started with a table and do a couple trials just to get your mind in the right space. If you want to do that and then shift to solving algebraically, you can do that too. All right, so let's take a look at problem A, and we'll solve that first, and then we'll move on to problem B. The person's height is positively associated with his or her arm span. Arm span being the distance between the ends of fingertips as arms are held out on each side of the body. One of the tallest men in history had an arm span that was 7 inches more than his height. So we've got two different measurements, the arm span and the height. The combined total of these was 221 inches. So our job is to figure out how tall was the man. So as we're going through and figuring this out, what do we notice? We've got a height, which would be X in this case, because the arm span was being compared to the height, and it said that the arm span was 7 inches more than the height. So that would have to be X plus 7. And the combined total, when you add the two together, is 221. So if we add height plus the arm span, you get 221. So we'll set it up as an equation like this. Go ahead and solve this equation. I'll pause as you work through that, and then we'll check to make sure that the answer makes sense. All right, let's see how you did. Add the two x's together, so that becomes 2x plus 7 equals 221. I want to know what the two x's were equal to before we added the 7, so let's subtract 221 by 7, and you get 214. So it's 214 plus 7, 221? Yes, it is. Two x's must be equal to 220 or 214. Now I want to figure out what x is equal to. So I'm going to divide 214 by 2, because 2 times x is 214, so 214 divided by 2 will tell us what x is, and that ends up being 107. So if that is the case, then I should be able to come over here and say, all right, 107 is the height. 7 more than that would be 114. If you add those together, what do we get? 221. That's what we were supposed to get. So we can declare our answer, x is equal to 107, but because this is a word problem, we need to declare it properly. How tall is the man? The man is 107 inches tall. So you can just write it like that. But that's the minimum. You can't just write the number. You got to also include the unit of measurement, which is inches. All right, second one. This one has to do with holding your breath. Humans can hold their breath on average 1 minute. However, animals can hold their breath much longer, especially animals that live in or around water. So we got 3 different animals here. We got the Greenland whale, can hold its breath for 3 times as long as the beaver. And then we've got a hippopotamus, which can hold its breath for 5 minutes less than the beaver. So once again, we have a nice situation where 2 of our variables are being compared to the beaver. So we should make our beaver the x. So the whale would be 3x, since it's 3 times as long as the beaver, which is our x. And then the hippo is 5 less than x, so we'd write that as x minus 5. The combined total, let's not forget that. That's important. All of them all together can hold their breath for a total of 95 minutes. So that would be the total. So if you add up the amount of time that the whale, the beaver, and the hippo can hold their breath, the total sum has to be 95, so we write that as our equation. Go ahead, pause the video, and solve for x for this particular situation. All right, so let's see how you did. 3 x's, 4 x's, there's a total of 5 x's here, minus the 5 gives you 95 for an answer. I want to know what the 5 x's were equal to before we took away the 5, so let's add 5 to 95 and we get 100. So is 100 minus 5 equal to 95? Yes, it is. So 5x equals 100. Now we'll divide 100 by 5, and you get 20 because 5 times 20 is 100. So that means the beaver can hold its breath underwater for 20 minutes. And the whale would be 3 times that, which would be 60 minutes. And the hippo is 5 minutes less than that, so that would be 15. Add those 3 together, and you get 95. That's what we wanted. So now, what are we declaring? How long can the beaver hold its breath? That's the answer right there. So we will declare that as 20 minutes for the beaver to hold its breath. And that is where we end today. Hooray. So now that we have blended together the 5D process with algebraic reasoning, now you've got the tools you need to solve any kind of a word problem, provided you work through the process the way you've been taught. Read the problem, pull out the essential information, see how the different variables or parts are related to each other, set up an equation, decide which one is going to be your x, and then solve for x, and you will be on your way to solving any kind of a word problem. All right? Take care. Bye.
Hey, feeling good. should. When in dark